So SohCahToa is super powerful for remembering like the basics of trig. And then if you mix that in with a couple other things that you know, then like for instance, the right triangle Pythagorean theorem, that'd be sort of like chocolate and peanut butter. Two great tastes that taste great together. This combined with the quadratic formula, and then the third one is the Pythagorean theorem. If you've got all of those, those are really, really good stuff. Okay, I don't know what would be the third thing that would go along with peanut butter and chocolate. Powdered sugar. Oh, that's true. And puppy chow, that is good stuff. Okay, so let's go to this. Your triangles don't come pre-labeled with those things. So they don't come pre-labeled, but I know the hypotenuse always has to be the biggest one. And the biggest one logically goes across from the biggest angle. See, if this angle here, the right angle, is open really wide, that means this side is the longest. Does that make sense to you? All right. And then of these two, this little symbol is for my angle. I don't know what my angle is, so I put a symbol for it. And that symbol is called, does anybody know that variable? Yes? Theta. With a TH, theta. All right, theta is one of those Greek symbols like pi is a Greek symbol. And you remember the one I gave you the other day? It was 1.618. Remember what the variable was for that one? Yes, the golden ratio, but it's phi, actually. Phi. Anyway, this one is the one you're going to use for mystery angles. Okay, so get used to seeing that one. Theta, say it. All right, good. That one tells me where I should put these two. Because if I put this theta down here, it changes these two. These two can be rearranged. Depends on where this is. So from this angle's perspective right here, adjacent and hypotenuse go like this. And the way you can remember this is adjacent means right next to. Okay? So if I am standing adjacent to Zach, and I'm standing adjacent to him, I'm right next to him. If I was opposite him, it would be like this. Does this make you uncomfortable? No. Good, good. All right. So, right across from is opposite. Right next to is adjacent. So now, this is just asking us to do that SohCahToa thing. What does sine stand for again? Opposite over hypotenuse. Okay. And that can be abbreviated just opposite over hypotenuse. Cosine is adjacent over hypotenuse, oopsie, and then the opposite over adjacent. Okay, good. You already know that stuff, just reminding you. Now, here's how they set up. And this is the one I'd put in your notes. Everybody, if you haven't already, get out your notes. Today is the 20th, and May 20, and the topic, more trig. And specifically, we're going to be using the trigonometric functions to find a missing side, but that's a pretty long title. All right, so the first thing I would do on this is I would label the sides. So everybody draw this triangle, if you haven't already. Okay, so the hypotenuse is always the one across from the right angle, and depends where the other two depend on where this one is. So this one makes this the adjacent side. I would just put them in when I'm just reminding myself how this works. We don't have to do this every time. All right, next I would say, which did I get given? I got given these two, the x and the 15, and they are the adjacent and the hypotenuse, and which function has adjacent and hypotenuse in it? Adjacent and opposite. I'm sorry, I said hypotenuse, but I meant opposite. A and O. Is it ever? Is anything like that? No, it's actually this over this. TOA, right? So tangent. And after your trig function, you always have a degree. 46 degrees in this case. If there wasn't a degree there, you'd have to put a variable there. There has to be a degree there. All right, and then I say equals, and then I say, what is it? Well, tangent is opposite over adjacent, so that means 15 over x. Okay. And I'm almost done. Now, at this point, we got to grab our calculators and take tangent of 46. You type it into your calculator. Half of you guys, actually more than half, will get the right answer, but then there's like a large number of you are going to type in tangent of 46 correctly, but your calculator will say something weird. Do you know why your calculator will say something weird? Andrew?
That's in degree, not radian.
It's degrees versus radians. You are correct. If your calculator said a negative answer, that's a giveaway that something's goofed up, and you go into your mode. Under mode, you're looking for degrees versus radians. All right, so how many of you found that your calculator was set on radians? I'm curious. 1, 2, 3, 4, 5, 6, 7 people. Okay, so that's about a third. That's pretty normal. All right, so get it fixed. Get it on degrees. And now, did you get some number somewhere around 1-ish? What did you get? 1.035. Now, if you rounded that to 1 at this point, you would disastrously change your answer. I mean, I know that doesn't seem like it's much, but when we're done here, I'll just show you the difference. Leave that on your calculator, and then say equals 15 over x. And then what would we do next? We'd multiply by x on both sides. X times 1.035, blah, blah, blah. Just leave it on your calculator. And now to get x alone, we divide by that number. So what we need to do on your calculator is use your knowledge of how that works and say, all I need to do is 15 divided by, and instead of retyping all that, just say answer. Do you know what I'm talking about? There's a key on your calculator that brings back the last answer that it was in its memory. So type in 15, divide by, answer. If you don't know where that is, it's second and then the negative key. All right, the final answer in this case, 14.4 something, 9 if I was going to round it. Do you see how if I had rounded that to 1, that I'd be doing 15 divided by 1, which would be what? What's 15 divided by 1? 15. So 14.49 compared to 15 is quite a bit different. Remember how I've been trying to pound on this a lot? Don't round until you hit the answer. If you round in the middle of the problem, you're going to get an answer that's all messed up. All right? So, much better answer to say 14.49 than to say 15. Because heck, 14.49 doesn't even round to 15. It rounds to 14. You're going to round it. Because 49 is less than 50, right? Don't you round or want to round it twice? Can't round progressively up. Otherwise, 14.25 could round to 15 in that case. Because wouldn't 14.25 round to 14.5? And then that would be the closest to 14.5. And my point is that's not, you can't do that. You can't round twice. All right, so let's move on. Just trying to say you should not round in the middle of a problem if you can avoid it. All right, here's another problem. I'm going to pause while you try to set this one up right. So once I got those labeled, I probably would have said, all right, I gave me this one, and that's hypotenuse and adjacent. That sounds like, oh yeah, cosine does adjacent and hypotenuse. So cosine always have to have a degree next, 32, equals an adjacent over hypotenuse, ka, from the SohCahToa. Adjacent is x over hypotenuse is 53. You use your calculator to figure this out right here. And then you just have to multiply both sides by 53. Don't round until you get to the very end. Final answer. In front row, Mr. H. Yes, 44.94. Raise your hand if you had the same thing. Okay, good. So, there's a couple of important... Oh, I got a question here. You have a question? Okay. All right. There's a couple of important triangles that you need to know, and I am going to start those at the beginning of the next video.